So this video is going to talk about VSEPR theory, which stands for valence shell electron pair repulsion theory. It's a new topic, but it actually includes a lot of topics that we've already covered. So quick review of those, and then we'll actually get to VSEPR theory. VSEPR theory helps us explain why certain chemicals have the properties that they do. It's all about the electron. The electron is the most important part of this explanation, and I will get to that in a second. So a quick recap of some of the things we've already done leading up to this. So we've been representing atoms using Lewis dot diagrams. So for example, sodium is in group 1. So to represent sodium, we just use the symbol as the nucleus and then the valence shell electrons. Remember that valence shell is the very outside shell. We don't need to worry too much about the inner shell electrons because those aren't directly involved in bonding, but we could have drawn sodium like that. So remember that the first shell holds 2 electrons and no more, second shell holds 8, third shell can hold 8, but really sodium only has 11 electrons. It's got an atomic number of 11. So 2, 8, 1 would be how the electrons are arranged. So either way is correct to represent sodium. So then for more complex molecules, we need to think about how they're actually arranged. So this will actually lead up to this in a moment. So let's say for H2O. So oxygen is in group 6. Remember, group number tells you how many electrons are in the valence shell. Oxygen's in group 6. So 6 electrons from oxygen. We're dealing with H2O, which is a molecule. Remember, a molecule contains at least 2 atoms covalently bonded together. The atoms can be different or they can be the same. In this case, you've got 1 oxygen and 2 hydrogens. So remember that the goal of bonding is for each element to complete its valence shell. So some elements lose electrons, some elements gain, and then some elements share. When we're dealing with covalent bonding and VSEPR theory and electronegativity and polarity, it all involves non-metals. Ionic bonding is the bonding between metals and non-metals, and we're going to get to that later on. But for right now, we're going to look at this molecule. So you have 2 hydrogens. Each hydrogen brings 1 electron, so it fills its shell by sharing 1 with the oxygen. Same with this one. So hydrogen now has 2 electrons around it. It didn't lose or gain, it's just sharing, so that's covalent bonding. Same for this hydrogen. Oxygen started off with 6 electrons, it shares 2 with each hydrogen, so that makes it have 8 in its valence shell. So this is a more stable arrangement than just a single atoms. But the question is, why did I arrange it like this? Why did I draw the 2 hydrogens next to each other, and why did I draw these electrons just up here? Why did I arrange it that way? Well, that actually, to answer that, we need to talk about VSEPR theory. And I'm going to redraw this oxygen slightly using the line diagrams. So remember that a line like this represents a covalent bond. As I had it before, a dot and a cross also represents a covalent bond. 1 covalent bond is 2 electrons being shared. But this also represents a covalent bond. But again, why did I draw it this way? Well, the reason is because the pairs of electrons, and this is a pair of electrons, this is a pair, and so obviously this is 2 pairs. These are slightly different, and they have slightly different properties, even though they're all electrons. So we'd call this the bonds that are being shared are bonded pairs of electrons. I'm using E with a negative sign above it to represent electrons. So these are bonded pairs of electrons. And so then for these 2 pairs, there's 2 ways to describe it, and you might see both. But they're all called lone or unbonded pairs. So shared electrons are bonded, that makes sense because it's a covalent bond. Lone pairs, they're lonely, they're unbonded with anything, so they would be called lone pairs. So the big idea of VSEPR or valence shell electron pair repulsion is that these pairs of electrons interact with each other slightly differently. And so before I move on, I'm actually going to pause this video and then have a different setup on the board which will help explain VSEPR theory.